Okay, so in our foldable, that was segment addition postulate, midpoint, and segment bisector. We're working on midpoints, so we're in the middle portion. So on the definition, a midpoint is a point on a line segment that divides the segment into two congruent parts. So I would just underline that. You've got two congruent or two equal parts. That is when it says midpoint. So let's draw a picture that goes with this right here. It says M is the midpoint of segment AB. So go ahead and just draw segment AB. Doesn't matter how long, just call it AB. Now M is the midpoint. That means it is in the middle. So try to estimate the best you can and put it in the middle. And then how we show that it is cutting it into two equal parts, it is in the middle. You show that AM is congruent to MB by putting these little hash marks right here. So since they each have one, these show that the two segments are congruent. So if it says M is the midpoint of AB, then you know that AM is congruent to MB, which tells you AM is equal to MB. And that's what knowing something's the midpoint does. Let's do the example. It says M is the midpoint of CD. It tells us that CM is 4x plus 12 and MD is 3x plus 14.5. So it wants us to draw a sketch representing this situation. In geometry, anytime you can, go ahead and draw an image if they don't give you one. It always will help clarify things. So I have segment CD, and then M is the midpoint. And I can mark that CM, this distance right here, is the same length as MD. And I mark that with the little hash marks. And I'm going to go ahead and label it. CM is 4x plus 12, and MD is 3x plus 14.5. All right, so now it wants us to solve. If you know that it's the midpoint, then you know that CM is equal to MD. So we go ahead and write that down. We can substitute for CM, 4x plus 12, and for MD, we can substitute in 3x plus 14.5. So that's the geometry portion. It's just understanding what midpoint is in the setup. From here, it turns into a problem that we would have completed in Algebra 1. So the solving is not too much of a struggle. It's just the setup, that's the geometry portion. So I'm going to move the x's to the same side. So I'm going to subtract the 3x. That gets me x, because 4x minus 3x is x, plus 12 equals, and then on this side I have 14.5. All right, so now we're trying to get x by itself. So next we're going to want to subtract 12. So 12 minus 12 is 0. That's where it goes away. 14.5 minus 12 is 2.5. And that's my answer for x. Let's look at the bottom part of our foldable about segment bisectors. So a segment bisector is a point, ray, line segment, or a plane that intersects the segment at its midpoint. So if the segment bisector intersects it at its midpoint, then that means it's in the middle. So the segment bisector bisects a segment, which means it cuts it into two, bi means two, equal sections or parts. So instead of bisect, you can think of as cuts into two equal parts. So let's go ahead and draw what this is. It says line CD is a segment bisector of segment AB. All right, so we have segment AB. Let's go ahead and just draw a line segment and call it AB. Now it says CD, line CD is the segment bisector. So that means it is doing the cutting. Now remember, it is bisecting it at its midpoint. So I'm going to put a point where I think it's in the middle. And CD, it said, was a line. So I'm going to draw a line going through the midpoint. Now I need to call it CD. So I'm just going to go ahead and call that C and put another point on the line and call it D. And so that's my segment bisector, and it's cutting this into two equal segments. I'm going to go ahead and draw that on there. All right, let's do the example on the foldable. So it says identify the segment bisector. So that wants you to tell you exactly what is doing the bisecting. So is it a point? Is it a line segment, a plane, a ray? So if you look at that, I highlighted the segment bisector. So the segment bisector is a line, and we can name it line MR. Sorry, I was writing with my highlighter there. It didn't turn out too hot. So let's go ahead and write MR. Okay, so now it wants us to solve for x. Well, since it's a segment bisector, we know, sorry about that, guys, we know that SM and MT are going to be equal. Because it's a segment bisector, it cuts it into two equal parts. So SM is x plus 12, and MT is 8x minus 2, and they're equal. So now that's the geometry portion, using the information, the vocabulary of segment bisector. Now we move on to the algebra portion, which is just solving. So I'm going to move the x's to the same side by subtracting x. So I have 12 equals 7x minus 2. I'm going to add the 2. So now I have the x's, I'm trying to get it by itself, so I have 14 equals 7x, and I divide by 7, so 2 equals x. And it did say solve for x, so that's my answer. Let's go ahead and look at our notes on example on 1.3. So example 1A on 1.3. It says, in the skateboard design, VW bisects XY. So VW is doing the cutting, XY is being cut. So right here you have XY, that's what's being cut. VW is bisecting. So VW is acting like the knife. So that means this part right here is equal to this part. So if you want to think about it, I'm just going to go ahead and draw it out here. So we have X, Y, and then VW. So we don't know that the VW is being cut in half, but we do know X and Y are being cut at point T into two equal parts. So it says XT, this portion, is 39.9 centimeters. And it wants us to find XY. So when it says find XY, that's this portion right here. So what we can do is, if this left side is 39.9, the right side is also, just because if it's cut into two equal parts, then both sides are equal to each other. So then you can either add them together or times by 2 to find out the whole distance, XY, is 79.8, and that's centimeters. All right, so on B, I want you to go ahead and identify the segment bisector of PQ. All right, so here's your segment bisector, and that is a ray. And so how we're going to name it is we're going to do MN with the ray symbol on top. So that is the segment bisector, is ray, MN. You have to do M first because when naming a ray, the endpoint comes first and then go towards the arrow for the second letter. Now it wants us to find how long PQ is. Well, if it's a segment bisector, PM, which is 1 7/8, is the same length as MQ. So this is also 1 7/8. So then to find the whole distance, we're going to do 1 7/8, and we're going to go ahead and times it by 2, and I end up with 3, sorry about that, I end up with 3.75 or 3 3/4. And you can put that in a calculator, or you can do it by hand. All right, example 2A, point M is the midpoint. So even if we didn't have these hash marks telling us they were congruent, we could add them ourselves just by knowing that M is the midpoint. So since it's the midpoint, that tells me that VM and MW are equal. So 4x minus 1 is equal to 3x plus 3. So to solve, we're going to go ahead and subtract the 3x. So I get x minus 1 equals 3, add the 1, and so I get x equals 4. Now that is not the answer because it did tell us to find the length of VM. So I need to know that, okay, VM is 4x minus 1. And so x is not my answer. I use the x to plug back in. So my x was 4. So I plug it back into the equation and I end up with 15 units. And that's my answer.